Now, we're trying to look at another example of velocity time graph, and I was trying to look at the example that a car, we've already drawn the graph on the board, but we re-explain the graph again. A car starting from rest accelerates uniformly and attains a speed of 80 meters per second. A car starting from rest, point O here, point O here, 80 meters per second. It attains a speed of 80 meters per second. That is what we got here, 80 meters per second in 30 seconds. When it starts from rest here, it attains the velocity of 80 meters per second in 30 seconds. That's how we arrive at here. So it maintains this steady speed for another 30 seconds. The car maintains the steady speed for another 30 seconds. That means that when it reaches 80 meters per second, it maintains the speed for another 30 seconds. It maintains the same speed for another 30 seconds. And to measure 30 seconds from here, now this 30, 10, 20, 10, 20, 30. So for another 30 seconds. It then slows down uniformly until it comes to rest in the next 40 seconds. This way it stopped before. This 10, 20, 30, 40. So in the next 40 seconds. Now, when the car starts from rest point O here, it reach the height, the velocity of 80 meters per second. It maintains the same speed for 30 seconds. Then slow down to come to rest in another 40 seconds. So, and this is the sketch of the graph. Now the question now says that sketch the velocity time graph for the motion of this car. We should sketch the velocity time graph for the motion of this car, and that is what we just sketched. So now, this time we should now obtain from the graph the uniform acceleration during the first stage of the journey. The uniform acceleration during the first stage of the journey, and the retardation during the last stage of the journey, and the retardation during the last stage of the journey. Now, so for how long did the car travel together? And for how long did the car travel together? So let's try to look at some solution of this question. So to find the acceleration along OA now, this will be equal to, okay, I've not, let me call, when this place is A and this place is B, we can call this place C, call here D, and this place E, whichever way you feel to label it. So it is okay. Now, acceleration A is equal to, acceleration along OA is equal to AC all over OC. AC all over OC. AC all over OC. That is the acceleration along OA. Because the question that what we are going to find there is, so this is what you find, which you obtain from the graph, the uniform acceleration during the first stage of the journey. The uniform acceleration during the first stage of the journey. So, and that is AC over OC. So when we want to find it, that's what we are going to do. Now, this will be equal to AC. Now, our AC is 80 meters per second. 80 meters per second. That's our AC all over OC. OC is what? 30. That is 30 all over 30 seconds. So all over 30 seconds. Now, to get the acceleration during the first stage of the journey now, we divide the 80 seconds by the 30 seconds, 80 meters per second by 30 seconds. So this can 30 seconds here, we have 30 seconds, 30 in 80. We are going to get 2.5 point. So we get something like 2 point. This cancel. 6, 7. So you're going to get 2.37. So 2.37 meter per second square. So 2.67 meter per second square. That is the acceleration. So for during the first stage of the journey. During the first stage of the journey. Now let's look into the retardation now. During the last stage of the journey. Retardation during the last stage of the journey. What we do here is the acceleration during the first stage, the retardation, which is the acceleration during the last stage of the journey. Now this is the gradient of the what? Before we do the gradient of OA. The retardation, according to what we did before, that is the gradient of BE. That is the gradient of BE. So, and the gradient of B, this will be equal to DE all over, so BD all over DE, sorry. So BD all over DE. That is the gradient along BE, which is the retardation. Retardation, this is equal to BD all over DE. All over DE. And this will give us BD all over DE. BD is 80 meters per second. This is equal to 80 meters per second all over DE. From D, 10, 20, 30, 40. That is 40 seconds. That is 40 seconds. 40 seconds. This will give us 80 divided by 40. That will be 2 meters per second square. That is the retardation. So retardation during the last stage of the journey. So retardation during the last travel of the journey. Now, what is the final question? The final question says that for how long did the car travel altogether? And that is very simple. At first, according to the question, so he said the car started from rest, accelerated uniformly, and attained a speed of 80 meters per second in 30 seconds. The car first traveled for 30 seconds. So for the car's first travel for 30 seconds, then from there, it maintained this steady speed for another 30 seconds. Another 30 seconds. So it then slows down uniformly until it comes to rest in the next 40 seconds. 40 seconds. Now, here are the whole time that the car used to travel the whole journey. So when it first started the first stage of the journey, it accelerated at 30 seconds. They now maintain the uniform acceleration for another 30 seconds. Then it now comes to rest for another 40 seconds. So looking at this now, we have 30 plus 30, 60 plus 40. That will give us 100 seconds. Here is the time that it takes the car altogether to finish the whole journey. So that is another example under the velocity time graph. It's a very simple interesting topic under physics, because if you read the question will even guide you on how you are going to solve the problem, which is as simple as that. Now, in our next class, we will be starting with cause of motion, which is what? The force. The force. Under here, we'll be talking about friction. Talk about the type of forces. So then we do some calculation under angular speed and velocity. So angular speed and velocity. So with this, we come to the end of today's class under the velocity time graph, the motion. Do not forget we are still dealing with motion. Thank you, all the viewers. Thank you again. I remember myself, Mr. Humpe. Till next week, Thursday, 4 o'clock, that we meet again for another interesting class in physics. Thank you, and God bless you all.